Nice to be in orbit.
I see the flying car industry as game-changing when it comes to not only future warfare, but future military operations, just as important, humanitarian relief operations, hurricane support, all the things that we do defense of the homeland. If you start thinking about these devices as nodes in a network, it fundamentally changes the game.
Agility Prime is a program with a vision of world impact. By partnering today with stakeholders across industries and agencies, we can set up the United States for this aerospace phenomenon. Potential outcomes are rewarding and transformative with both military and commercial applications.
I want to offer my congratulations to Dr. Roper and his team for achieving this revolutionary rapid contracting and prototyping method to bring industry and DoD together to develop this new exciting technology with both military and civilian applications. This technology will have great benefit to the needs that we have in Alaska and the Arctic, where conventional aircraft, vehicles, and vessels oftentimes can't operate.
Agility Prime is part of our Defense Department's long history of turning futuristic ideas into reality. I'm proud that the federal government is investing in revolutionary ideas. Agility Prime is leading the way.
This launch of Agility Prime is so exciting. This technology has the potential to make vertical flight more affordable and more widely available. And with the encouragement of the U.S. Air Force and the entire federal government, American companies employing American workers can gain a head start and win a fair share of this lucrative market. eVTOLs have the same agile, vertical takeoff and landing capability as helicopters, but are quieter and should cost much less to operate because of their electric motors.
We are becoming a trusted innovation partner in commercial tech. I could not be prouder of this initiative. I could not be prouder of this team. And I am excited to see how quickly we can go to help commercialize this market for our nation so that our warfighters have options they don't have today, and our nation has an economic advantage far into the future. Innovation is a battlefield, and Agility Prime is just one way we're going to win it.
Agility Prime seeks to ensure a global advantage in advanced logistics technology. Agility Prime can reduce the risk of adversary commercial dominance, resulting in military disadvantage. As the United States Air Force looks at generating combat power away from runways, those distributed logistics aircraft must be runway independent. This new transformative capability is a promising opportunity to conduct that mission in an affordable and a scalable manner.
Today we gather for Agility Prime to drive transportation innovation, lower barriers to entry, and expand our partnerships.
We see a time when automation technologies make the requirements on the pilot much less. And we see flying as being accessible to a much wider range of people.
It is truly a great credit to Agility Prime. They could put on this virtual event with so many hometowns of the United States represented. You know, industrial base is not really about just what a country can make. More than that, it's about the people who dream up what to make. And then, of course, those people who make it.
Good afternoon and welcome back to the Agility Prime Team Up event. We've had a fantastic morning with over 250 different universities, different industry suppliers, manufacturers of electric vertical takeoff and landing aircraft available to have conversations to team up for this event in preparation for our upcoming closure of the proposal period that we have for this small business technology transfer program. Yesterday, you had the chance to hear from members of Congress, from Air Force leadership, and in particular, given the AFWERX recent transition to Wright-Patterson Air Force Base, Ohio, the leadership of state and local officials in Ohio. And if you had a chance to get onto this ecosystem that we have available online, you also had a chance to hear from a multitude of other state and local entities around the country that are posturing themselves to make sure that we have a leadership in this particular industry. So I want to remind everyone, those 254 different companies that are out there now, and research institutions, enablers for this new industry, that is not something that goes away when we're done today. That is a capability that we intend to keep up, and you'll hear more about that today. So I'd like to give you a little bit of a preview of what we're going to cover over the next 2 hours. Begin by talking with Sebastian Thrun about recent launch of their newest aircraft. We will then move over to our next guests from Phoenix. We'll talk then in detail about some of the approaches to outreach and connectivity between our universities and the small businesses that are out there. And then we'll close with the discussion with our NASA partners about the supply chain and what's necessary to make sure that we have the longevity that we need. We have the depth of this supply chain across the multitude of different technologies that are going to enable this in the future. So really excited to have you here for this next couple of hours. And in particular, excited to have with us here, Sebastian Thrun of Kitty Hawk. He is the CEO there, recently launched the Heaviside eVTOL. He's going to talk to us about that particular aircraft, about the exciting future that we have in electric vertical takeoff and landing aircraft. So Sebastian, thanks so much for joining us this afternoon. Thanks for the impressive work that your team is doing to advance this market. And over to you to tell us more.
Thank you, Nate. Thank you for inviting me. I'm really excited about the work you're doing and your team is doing. It's going to make a huge difference. And thanks for bringing us all together so well. I'm really impressed. I've been asked to fill about 30 minutes, and I'll give a presentation, but I'm very happy to have a discussion afterwards. So let me start with my slides. This is my title slide. My name is Sebastian Thrun. See if this works. Is the slide visible?
Yes, that's showing well. Thanks.
Good. So you see my self-image, my glorified self-image. My name is Sebastian Thrun. My history is I'm historically a college professor at Stanford University. Probably what you might have heard about is self-driving cars. Long time ago, I worked with the US government on something called the DARPA Grand Challenge to build cars that could race in the desert and drive themselves. And then eventually I found my way into Google, where I built the Waymo team, which is probably the most advanced self-driving car team in the world today. But since 2010, my good friend Larry Page and I have been involved in eVTOL. Back in the day, it was very visionary. Back in the day, no one took us seriously. Now, still no one takes us seriously, to be honest. I think the world has not woken up to the potential, but we made some progress. And not just us, there's about 250 different projects in the world. Some very, very serious, some with hundreds of millions of dollars of funding, chasing this dream. Okay, so what I thought I'd do is I lay out what the dream is, what is it not, what the challenges are, and then report a bit on the progress we've made at Kitty Hawk. And I have 4 slides on myths of what people get wrong about this stuff. And they're not really aimed at a specific application, like a military application, but much more of a societal uses technology as a new means of transportation. So what is the promise? Okay, so the eVTOL promise, the idea is to build electrically propelled aircraft that feel and look a bit like drones, like hobby drones, but bigger, capable of carrying people, and make them so they take off and land vertically, but fly like conventional aircraft horizontally. Why would one do this? I see at least 5 arguments why this is a useful concept. And you can happily poke holes into those because I don't think we've proven those. But that's the promise. I think a eVTOL aircraft has the potential to provide unprecedented safety. And the reason is all the consoles are being, or almost all of them are being built right now, try to avoid single point of failures the way a helicopter would have it. I'm also going to talk about operational safety by flying them the same way you fly a hobby drone. They're actually much easier to operate than a helicopter. They have zero emission. Now, zero emission is always a lie. In reality, you always have emissions. But by using batteries, at least while you're being en route, you don't emit anything. Zero noise is also a lie, but I'm going to argue we're very, very close to zero noise. And I'll give you some hard data. Easy to operate. We found that in massive tests where we had hundreds of people try these things out, it takes about an hour or so to become a safe operator. It takes less time than it takes to ride a bicycle. And then, of course, eventually we want them to be cost efficient. And there's many reasons to believe that the cost per mile for these eVTOL systems will be south of the cost per mile of car ownership when all is said and done. But again, there's a lot of belief in here, a lot of hype in here that hasn't been realized yet. What are the challenges? Well, the biggest challenges are performance, right? Because you confine yourself to a battery, you have roughly 1% of the energy density of fossil fuels. And that cuts massively into what you want, like range or speed or payload capability. And that's, I think, the Achilles heel of eVTOL. Can you get to a range or speed or payload that makes you fly more than, I don't know, 10 miles? There's been a recent study, investigation of a German company in that space. Someone published an article that analyzed the potential range and arrived at a range of about 10 miles until the battery is empty. And that was based on specific specs of specific vehicles. You might have seen EHang or Volocopter. Those are relatively slow flying vehicles. There's a question whether the wind blows, can they still fly upwind? So there are some very serious questions about specs. And of course, there's questions about safety. I think no one has yet shown that these things are actually safe as opposed to theoretically safe. So let's say a few words about our company. My company, or our company, Kitty Hawk, was founded by Larry Page and myself in 2010. So we've been on it for about 10 years. We've built about 20 different types of prototypes and flown about 130 different aircrafts. We have now roughly 27,000 test flights behind that, about 10% of them manned, 90% unmanned. We've been flying manned since 2015. I'll give you some specs of the most recent vehicle in a minute, but we've flown, we fly at about 170, 180 miles per hour at a range of 100 miles. And that's probably as far as you can expect to right now, anything reasonable. Beyond this, it's probably just hype. And we try to be quiet. And I'm going to argue that there's an unprecedented level of noise, quietness. That's just really amazing. So our first vehicle that we built in the first years recently became a joint venture with Boeing called Whisk. The vehicle is called Cora. We built about 10 of those. And those vehicles, as you look at them, have a separate lift assembly comprised of 12 carbon composite lift fans with specific high torque motors that we built in-house. And a push-up propeller, roughly 200 horsepower electric, that would then propel the vehicle to roughly 120 knots. And those have flown many, many times. Those are actually being on the path of being not just airworthiness certificated, but being deployed as an air taxi system in New Zealand. New Zealand, because the New Zealand regulatory framework is much more open towards heavy scale drones than the US is right now. We've built this vehicle. We actually built more than 100 of those. This was literally a human drone. You sit inside and you fly it like a drone. It's a ton of fun. This is the one where we had the most third-party people fly it. We had journalists fly it. At some point, we invited 50 people to fly it, but the specs weren't very good. It wasn't very fast or go very fast. So we did this and we sunset this entire program about a month ago. This is the one that's the most active one. It's called Heaviside. It is a winged vehicle that uses tilt rotors. These tilt rotors are actually mounted behind the wings. The thing is actually forward swept. And they can go from vertical takeoff to horizontal flight in roughly 20 seconds. And as they tilt, they also tilt the propeller pitch angle, making it efficient both for hover with a small advance ratio and for cruise with a steep advance ratio. And I'm going to mostly talk about this vehicle because it's the most advanced we've built. There's a video here where you can see it fly. We've built roughly, let's see, 10 of them and flown them. We fly them right now unmanned, just for safety. Unmanned lets us really test the vehicle at ways we would never do with a person inside. We do even mild aerobatic maneuvers. We test multiple motor outs, and we've already demonstrated we can lose one complete motor system and still fly it the same way. We can lose two, and if they're both on the same side, we can still land the vehicle safely. So there's an enormous redundancy that, at least in theory, will result in safety. So here's a test of a motor out, single motor out, you won't even notice. We have triply redundant ailerons and rudders and elevators. So we can lose those. They're all fly-by-wire. It's actually probably the smallest fly-by-wire plane ever attempting to get Part 23 certification in the United States. At about 40% thrust, we go 180 miles per hour. We haven't pushed further. And then, as I mentioned, because we fly unmanned, we can do all kinds of crazy stuff, like mild aerobatic maneuvers, just to understand what the limits of technology is going to be. Everything's said and done. So that, to me, is kind of defines what we are able to do. We're trying to stall this thing. It's very hard to stall, turns out. And then you see it as it goes back to landing mode, that actually really lands. These are multiple different planes that all land vertically in a small spot. So on specs, because specs is, I think, the Achilles heel of this technology, these are specs we demonstrated. And I think they're going to get better. But we've flown, I think, 102 miles plus 25% reserve. And it's not downwind. It's like actually in a big circle. So we didn't cheat. We use about 105 watt-hours per mile. I'm going to talk about this later. And our payload is limited. It's a single person plus a bag. So it's a single occupancy vehicle. And I know that many people are building 5-seaters, and there's really utility to 5-seaters. We believe that a single seater is going to be more versatile, but it's an open debate. So let's talk about in more detail about some of the implications. Now, when I talk to laymen about it, I often think of this not as a new aircraft that might replace helicopters, but more of an alternative to cars. And I love rubbing it in. So if you fly like 150 miles per hour straight line from San Francisco to Berkeley, those of us who live in the Bay Area know that this commute is lethal. It can take an hour by car. It's going to take 3 minutes. And the power consumption is so low that you're going to spend only 6 cents on energy. Same for Manhattan, is even more extreme. Turns out Manhattan is actually very small geographically. So from Jersey City to Midtown Times Square might take you a minute and 4 cents of energy. And of course, since many of you live in DC, from Washington to Dallas, it's maybe 8 minutes and 17 cents of energy. So it gives you kind of a scale of where we are. We actually are seriously talking to application fields like first responders. And Nate and I have talked about this quite a bit in the context of the military. We did a recent study with a provider who lives in Denmark. The company is called Falk, and they have historical data of emergency response data for the relatively small island of Zealand. Zealand is the Denmark is a small country. Think Rhode Island. And inside Denmark, there's an even smaller island called Zealand. It's the old Zealand. It's the location of the capital. And roughly 2 to 3 million people live there. I think 3 million people. And obviously, Falk, our partner, has historical ambulance data. And then on that, we kind of asked the question, what if we have like a small number of eVTOLs stationed across this country and provide first responder services? And as you might expect, even if you factor in a few seconds for mobilization and a few seconds for landing and hovering, you'll still, and I'll put this on the next slide here, you get some really nice advantages. You'll just be much faster. So whether you're a first responder, whether you're a commuter, whether you're in theater and need to do a search and rescue or whatever mission, you'll be faster and you'll be more energy efficient than you'll be on the ground. And that's, I think, is the great promise here. And I think with the specs that we've documented in Heaviside, we're at least at a point where we could compete or take over for most people that daily commute. Like daily commutes in the Bay Area are roughly 18 miles. They take roughly 52 minutes per day. And we could cut this down to 5 minutes and give people back roughly 200 hours of commute time per year of wasted commute time. It's actually quite a bit when you work together, how much time you spend in the Beltway waiting for these other cars when you commute. It's quite a bit of time that we lose. Let me talk a few words about myths, and that's something that I think people's intuition are often wrong when it comes to this technology. And I know most of you who know helicopters really well will not be fooled by this, but common people that I talk to are usually fooled. Let me talk about the first myth. The first myth is that flying is inefficient. Okay, so people will tell me, you know what, it can't be efficient to have something in the sky. It'll be less efficient on the ground. And that's just completely wrong. In fact, energy-wise, you will be and you are more efficient in the sky. We've proven it, but I'm also going to give you the narrative why that's the case, okay? So for pilots, if there's pilots among you, you've seen this diagram. It's part of your private pilot certification test. It's called the L/D diagram, or the total drag diagram. And as a pilot, you learn when you go slow, your drag is mostly there to keep you up in the air. It's called induced drag. That's the green curve. When you go fast, your drag is mostly parasite drag, which is the drag that occurs because your plane is like replacing air really fast as you move really fast. And parasite drag exists for cars and airplanes alike. Okay, in fact, it tends to be larger for cars for many, many reasons. One is we don't want cars to get airborne or be affected by crosswind the same way planes can be. As a pilot, you learn the total drag minimum is where parasite drag and induced drag is the same. When you fly at that speed, it's really true half your energy is being used to keep you up in the air. That's the induced drag. And the other half of your energy is being used to fly you forward. But as this little ellipse here indicates, most planes fly at a much, much higher speed. In fact, most planes fly inefficiently because people care more about getting to a location fast than flying at the range optimized speed. So if you fly a commercial jet, 5 to 10% is being used for staying up in the air, and 90% is being used for parasite drag, which means whether you're on the ground or up in the air, it'd be the same. In fact, if you go high up in the air, it's less because the air is thinner. We all know that the true airspace increases relative to indicated airspace as you go high up, and you go in a straight line. So you save roughly 15% of distance if you go airborne as opposed to ground-based. So that means to me, flying will be more efficient than driving. That's actually a counterintuitive surprise. In fact, give you hard data. When you take a Tesla Model 3, you get roughly 300 watt-hours per mile. That's the energy consumed per mile at 60 miles per hour, okay? We know our drag goes up quadratically. Heaviside uses about 105 watt-hours per mile at 120 miles per hour, okay? So you put these numbers together, you'll find in the workout that Tesla has an average occupancy of 1.43 or so. You'll find that our plane is roughly 3 times as efficient, or 2 to 3 times as efficient as the most energy efficient car on the market today. And that's necessary because we are dealing with batteries. As I mentioned, the biggest challenge are those specs, and you have to build a really efficient airfoil. If you don't build an efficient airfoil, for example, like Flyer, then you won't get those specs and you use much more energy. And then basically you're tying your hands behind your back. A nice thing about a really well-designed wing is that you can actually really compete and get a really environmentally friendly vehicle. Myth number 2, okay? Flying is unsafe. Apologize for the misformatting on the left side. So flying is unsafe. When flying is unsafe, okay? And that's something that I think, yeah, intuitively it's true. If you fly and you crash, you tend to die. If you drive and you crash, you tend to not die. That's correct. But if you look at the statistics, in the US alone, we have roughly 34,000 traffic deaths every year. In fact, the number is going up right now because of cell phone use. Although 2020 will be lower because of COVID. COVID is actually saving lots of traffic lives. But in commercial aviation, this year, last year, the year before in the United States, the death is 0. The GA deaths are roughly 250 to 300. But it's actually amazingly safe. And it's really a compliment to the FAA and to the military to have come up with regulations and techniques to keep the skies safe. That's an amazing accomplishment. And that's something people often don't see. If you graph what is the safest way per mile traveled, and you take out like the space shuttle, because most of us can't take that to work, you find that commercial aviation is much safer than even trains or buses or cars. So it's actually very safe. So we strive to have the same safety for our vehicle when everything is said and done that we find in commercial aviation. The next one is one that blows people's mind. The sky will be crowded. So the common question when I give a talk is, hey, Sebastian, when all the cars are up in the sky, won't we have the same traffic jam? And the answer is a resounding no, because roads are one-dimensional and the sky is three-dimensional, okay? That's kind of exponential in some sense. If you take a road of 1,000 feet length and fill it with cars, bumper to bumper, you will have 64 cars. If you take, hypothetically, I'm not saying you're going to do this, but hypothetically, you take a cube of 1,000 by 1,000 by 1,000 feet. So you're now three-dimensional, okay? How many cars will fit? Well, I did the work for the typical American sedan, door to door, roof to bottom, and bumper to bumper, and it'll be more than 1.7 million cars. And that's because if you wanted, for example, to take a highway like Highway 101 here in the Bay Area that has typically 3 lanes and give it 30 lanes, you just vertically recompile your software and define 30 lanes at 10 layers, and you have 30 lanes. And that's something we can't do on highways. So if you ask yourself, how can you expand traffic capability in a country like the United States? The only real way is to go in the air. And the beautiful thing about the air is you need no infrastructure. You can just do it, whereas everything else needs infrastructure. Let me talk about congestion, about noise. And that's something that we're very, very proud of. In fact, if you listen to Seth Rogen's interview of Elon Musk a few weeks ago, he makes this very strong claim that electric aircraft will obviously be noisy. And I think we've eventually been able to refute this, at least in overflight. When Flyer flies over you at 1,000 feet, we roughly get 35 to 38 decibels. And just to put this into perspective, a whisper is 30 decibels, a refrigerator is 40 decibels, moderate rain is 50. A helicopter, you see this on the bottom right, is 100 decibels, and the jet engine is 130. And this is obviously a logarithmic scale. So when we fly in the field and birds are chirping, the birds are actually noisier than our aircraft flying at 1,000 feet overhead. It's basically as quiet as a glider. It's a bit more noisy in takeoff and landing. It roughly gets, if you're at 50 feet, very close, it roughly gets to 85 decibels. But we don't have a cool down period or a warm up period. So even if we land, within about 10 seconds or so, the landing noise disappears. You have a very short burst of energy. And we're working really hard to make even the takeoff and landing noise less. But in principle, I think that proves that eVTOL can be really, really quiet. And I think it's important, not just for military applications, but also for civilian, because if the vision is we're going to congest the sky at some point with eVTOL vehicles, I don't think people would like that if they're as noisy as helicopters. The fourth myth I want to address is when you Google eVTOL, then you find massive number of images like those guys over here, renderings that invent these new vertiports or skyports. And I think that's just wrong. I think the right answer ought to be they can land wherever you want to land them. That's not entirely correct. I mean, sometimes you have power wires that overland and so on. Obviously, you don't want to land them on a highway or a busy street. But something like Heaviside needs roughly the size of half of a tennis court. So if we dedicated, say, all the tennis courts or all the Safeway parking lots to eVTOL, and later on, maybe even street intersections or residential streets, you could envision a world where you could literally take this thing in front of your house and fly yourself to your office and back and have minimum walking distance. Just to put this in perspective, we are today dedicating a huge amount of land mass to transportation. In Los Angeles alone, if you just look at the amount of real estate, the land dedicated to roads and highways and driveways and garages, basically to transportation, it's roughly 60%. It's more than half. And the nice thing about eVTOL is you don't need roads, right? So you can eventually eliminate roads and then regain this land and really focus on a small number of areas where you take off and land. And I don't think we need massive infrastructure. So I think the pictures you find on the web that draw these incredibly illusionary, almost mushroom-shaped buildings aren't needed. You really need, all you need is an electric charger that's the same as your car charger. In fact, the batteries we use is roughly 18 kilowatt hours, and it can be charged in half an hour on Heaviside alone. So that's my perspective. I'm super happy to have a discussion. And with that, I'm going to try to see if I can make my face reappear. Here I am.
Sebastian, fantastic. Thanks so much. Really a fascinating look at this as we've toured around through Agility Prime to see some of the challenges that are out there. Having you highlight kind of back to the basic principles in so many of these things, I think is really helpful. You clearly are one of the leaders in thinking about autonomy, and this clearly, as we go forward, thoughts on safety, potentially thoughts on reducing folks that are wearing wings on their shoulders for us in the military. As you look at this, can you give us a little bit of a story? You're setting in 2035. What is the path that you see that gets both the cultural acceptance, it's regulatory acceptance, and makes everyone at a level of comfort to get all the benefits that potentially seen in autonomy? I think starting from your role, which you did in the DARPA Grand Challenge, you've seen this a bit. You've had 15 some years looking at this on the ground. What does it look like in the skies?
So first of all, great question, and I just want to reinforce what you say is very correct. First, let's talk about the vision. 2010, we sat together and Larry made this great observation that he'd just gotten himself a DJI drone and unpacked it, and it took him like 3 minutes how to learn to fly it. And when something went wrong, there was a return to base button. When you let the hands go, the thing parked itself. And they're just so different from helicopters, right? Helicopters are dangerous beasts. It takes many, many hours to even hover it. So obviously there's an opportunity here to do the same magic that we do for drones for aircraft. And that's something I think should happen everywhere. I'm a private pilot. I'm working on my commercial. I can't tell you how sad I feel that I have to do all these crazy things that a computer could just do for me. Like, why do I have to monitor airspeed or align myself with the runway or put the flaps up or the gear up? And if I get to gear up, my God, then my drag goes up, or even lean the mixture. So I think there's a future in aviation where these computer systems become safe enough we can rely on them. And for heaviside, because it has 8 distributed rotors, it's impossible to fly it by hand. It has to be flown by a computer. And we are in the process of basically using DLB as a safety standard to certify the flight control system for this vehicle, so it's basically as safe as a small commercial jet. We are very fortunate that the FAA has decided to rewrite Part 23 in the last years under the leadership of Mike Huerta, from a formulaic set of regulations to a performance set of regulations. We are also incredibly lucky, and I hate to say this, that coronavirus hit, because it completely changed the interaction with federal agencies. Before coronavirus, meeting with people meant you physically go to the same location, typically Kansas City. Now it means you go on Zoom. So we now have roughly 2 to 3 meetings a week with the FAA, just very brief meetings, just briefly talking about what are the open questions and the open concerns. Now, in certifying heaviside as a type certifying as a safe Part 23, there are real challenges, and I tell you some, right? So there's no proven track record of large lithium-ion batteries on aircraft. There's no small general aircraft that would use a fly-by-wire system. There is lack of clarity on the pilot licensing requirement, because technically we are a powered lift, but practically speaking, the only way to become a powered lift pilot is to be flying for the Air Force. There's no civilian powered lift that I'm aware of. I think Osprey is going to become one. So there's challenges, but I found the FAA to be incredibly open-minded and a really good partner in all this. And I'm very confident that in roughly 3 years' time, we're going to have a type certification.
Super. You had talked a little bit about, you had spent some time with DARPA. What do you see, not with DARPA, but in the DARPA Grand Challenge as a DARPA Grand Challenge? What do you see a bit? You said the great things about the FAA, and we certainly have a fantastic partnership with them. It's exciting to see everything they're doing to help drive this industry. What do you see as the role with government in being able to accelerate this industry and do the things you mentioned? The frequent discussions with FAA. Where can we help as government? Where are the places where we slow things down the most? What's your recommendation to try to accelerate this and the role of government in doing that?
Yeah, I mean, that's probably a question I would ask you, because you know much better. I know there's an amazing interest in fast iteration. My friend Ash Carter started DIU, the Defense Innovation Unit, which is a really great entity in Silicon Valley. Obviously, the fact that Agility Prime exists is amazing, and that's just a really great signal that there's a real interest in promoting innovation. And I fully recognize you're dealing with tax money and you have obligations. We can't just hand out checks to people you like, the way we do this in private industry. I would say when I talk to the government, I think at some level we got to be really great partners, right? When I take my conversation with the FAA, I would argue we have exactly the same interest. We are both interested in safety first. There's no question. If my plane crashes and kills my customers, that's not a good product. And we're both interested in innovation. And we are interested in, I'm interested in national defense. I'm interested in staying safe. And I have incredible respect for people who keep us safe. So with that, we find, practically speaking, that the FAA has brought to the table a level of expertise we just don't have, and makes us aware of things we haven't thought about. And as a result, the plane has already become much safer. So these partnerships are great. I think sometimes they go wrong because people get impatient. And impatience is just not good. Because as long as we all want the same thing, you want safety and innovation, these two things, I think working together is going to be the fastest way possible. And honestly, Nate, you and your team reaching out to us so many times, it's just such a, and starting these amazing programs, it's just such a great example of government doing exactly the right thing to push innovation forward.
Super. So one more question. You also co-founder of Udacity. Any thoughts on what the future of learning looks like? For me, spent 12 months learning to do basic flight in the T-38, another year in the F-16. Any thoughts you have on education, particularly with regard to flying? Certainly, it looks like it might be simple into the future. But any ideas on lessons learned that you might offer for us as a military and being able to do our training and education in different ways?
Yeah, so this is a complete different conversation thread, and there's no connection to Kitty Hawk, but Udacity is a company, it's an online education company that really specializes on giving people tech skills, or management skills, like the latest skills. And it's based on the observation that technology is moving now so fast that it's very hard to keep track of what's going on. We are working with the military, with the Air Force, with the Army. We're working with 6 different countries, working with the White House. We're working with almost all Fortune 500 companies. And we upskill people. It's all online. It's all affordable. If you care about artificial intelligence, you care about flying cars, you care about self-driving cars, or you manage these projects, you can come to us and take courses and even get a certificate. We call it a nano-degree certificate. The future is interesting. You're raising a great question. I think when you look at innovation, in addition to having a great vision, you need the right talent. And talent is something that you can finesse. It's not just you're born with talent and that's it. Talent means skills. Like if you're, for example, my age and you're in your mid-50s, I am, my computer science education is completely outdated. Nothing of what I learned applies to today. And if I stay with that state of knowledge, there's just no way I can make a contribution. The only way I can make a contribution is to keep myself educated. And that calls for an era of lifelong learning. I really believe in the future, all of us will spend 10 minutes a day learning something interesting for the rest of our lives. We're going to use learning the same we use toothbrushes, twice 5 minutes a day. And when that happens, then people can continue, adapt to new technologies, use technologies, and have a much bigger impact in life.
Sebastian, thanks so much for the time. Clearly, that workforce of the future development is something that we are keenly interested here with Agility Prime. Thanks for the opportunity for the learning that we had here with you this afternoon, and looking forward to continuing that into the future. Thanks so much.
Thank you so much for having me.
All right, take care. Next up, we have, as we've mentioned, since the launch of Agility Prime back in April, we've had a variety of new entrants into this air race to certification. One of the companies that has recently come forward in this air race and is making great strides is here with us today and going to tell us a little bit about and offer some video here. So we have with us Brian Reese, who is the CEO of Phoenix Solutions. Brian, thanks for joining us this afternoon and welcome. Thanks for the partnership with Agility Prime, and looking forward to hearing more about what you're doing with Phoenix Solutions.
Yeah, absolutely, Nate. Really appreciate the opportunity. And as Nate said, again, I'm Brian Reese, president of Phoenix Solutions. And again, on behalf of the team here in the Pacific Northwest, I'd like to extend our appreciation to the Agility Prime team for the hard work and the focused energy for this team up event. This is absolutely top notch and fantastic. So for the rest of the group, as Nate mentioned, we're participating in AOI number 3 with our heavy vertical lift rotary UAS systems. And we recently completed our phase 2 demonstration to the Agility Prime team. We're moving forward to advance the flight test and certification program, and we're doing that in concert with the Air Force. But as for the flight testing and the certification itself, we're also working with the Alaska UAS test site and collaborating to enroll R2 air vehicle platforms, which you'll see in the video here this September. This really begins our journey down the path for civil certification. Again, this effort is greatly influenced by the hard work and support of Agility Prime, the associated ecosystem, our STTR, and our research partners. So with that, I'd like to show you a short video that chronicles our development over the past few years. And also part 2 of this video will showcase our user or operator-defined modular payload mission sets that have informed our performance goals for the vehicles themselves, but also our flight test and our certification targets as well. So thank you. If you could cue up the video, please. Good afternoon. It's great to be invited to be a part of the Agility Prime ecosystem. We are proud to present a short 5-minute video clip chronicling the inspiration and evolution of our heavy vertical lift rotary UAS system. Our journey started over 8 years ago with the development of our proof of concept, HeliLift 200. This platform proved the viability of our patented jet engine bifurcated ducted exhaust system that reliably and efficiently rotates the blades, the heartbeat of the cockpit. The HeliLift program delivered positive results, and flight testing showed exciting promise for control, maneuverability, and performance. Girded by this success, we then raised the ante by increasing turbine engine power and designed a patented electric yaw control. This eliminates the need for gear and transfer boxes, pulley belts, and shafts, and eliminates the tail rotor and tail boom, thus shrinking the physical footprint of the machine while maintaining sterling flight control properties throughout the envelope. Success of the single 550 with electric yaw control demonstrated a pitch-perfect marriage between performance, simplicity, and deployability. The copter and all accessories easily folds for containerization and shipment, where it can quickly be put into operation in less than 1 hour. The maiden flight of the single 550 was conducted in September of 2019, and the results that we achieved from this initial flight test couldn't have been more promising. We continue to make improvements to the single 550 by adding cyclic and collective controls. Flight testing for these improvements are continuing to this day. With the success of the HeliLift and the single 550, you now may be starting to notice a trend. You guessed it, more innovation, more performance. Enter the Quad 550. With an objective to attain an astonishing payload weight of over 2,000 pounds, we began the long journey to perfect the design and apply the lessons learned from the bifurcated exhaust design into a simple, efficient, and reliable platform. The hard work began, and each day was a voyage of discovery. We tried various configurations, materials, avionics solutions, and add-ons. From our initial rudimentary design approach, we overcame vibration, overheating, resonance, cavitation, and performance challenges. A key breakthrough for the quad was balancing between internal and external drag in the rotating thrust arms. Once perfected, the overall platform resulted in an elegant expression of material, engineering, and know-how that demonstrates significant potential to serve many heavy-lift rotary wing missions today. We like to say that our copters are fashioned from passion, and it is said that there are typically 3 responses to any design: yes, no, and wow. Wow is where we are going, and we would very much like to see you join us on this journey. Together, we can change the landscape and make exciting contributions that support our shared goals. Thank you for your time today. Our team brings world-class, user-defined modular payloading capabilities to the table. We intend to leverage this pedigree from current manned rotary wing markets and transition those products to best serve operators with proven unmanned solutions. With Simplex Aerospace on board, we bring over 75 years of industry-leading design, manufacturing, and market-certified solutions for the helicopter and aerospace industry. Key aerial applications include fire suppression, precision ag, aerial industrial cleaning, spill response, and many more. Probably one of the most unique and equally terrifying examples of our aerial mission equipment is this presentation on the vertical and horizontal saw. Enjoy. Now that is some hedge trimmer. Here's another fine example of our manufacturing agility in action, the Sky Cannon. This is a purpose-built, Simplex-developed piece of aerial mission equipment that can be used for a number of missions, from urban fire attack, power line cleaning, and wind turbine blade cleaning. Watch this short video from one of our customers. As you can see, we have tremendous worldwide relationships with operators. Many in this community are eagerly awaiting the development of unmanned platforms to perform these very specialized and dangerous missions. With an impressive lineup of over 850 STCs and 5,000 products, our team offers a comprehensive portfolio of capabilities. We are mission ready. Okay, so thank you. I think we're back. I hope you enjoyed the video. We're very proud of it, and we're also very grateful for the opportunity to participate in the Air Race 2 certification, as well as to interact with, network, and meet everyone in the ecosystem. In fact, I'll tell you a short story before I turn it over to the rest of the group and over to Nate. But this is a little short story from yesterday. I was manning the virtual booth, and a very nice, well-mannered and respectful ROTC cadet entered the chat, and he asked me if he could do a quick survey. And then, of course, I said, sure. And so his first question was, what separates or distinguishes you from other vendors in this space? And I said, I thought about it for a little bit, and I said, now, gosh, I don't really know many of the folks in this space, so I really couldn't say. But what I did do is I went on to mention that the significant thing to point out in the survey question with this space, whatever you want to call it, eVTOL, flying cars, urban air mobility. I've heard references earlier to the Jetsons or Buck Rogers or whatever. But what is completely different here, I think, is something that Dr. Roper said during the launch event, that Agility Prime is a departure from the traditional defense acquisition, where you might, fight your competitor to the death for that first contract, or you may never see it. This, to me, is a complete change. The Air Force has adopted a posture that seeks to cultivate innovation and support the industry broadly. So in the case for vendors, we're all either developing technology, applying old technology in new ways, or some combination of the two. But we're doing this to bring value to the markets we serve, or in many cases, creating new markets themselves. So from a vendor perspective, I think a high tide raises all ships, and Agility Prime delivers against this notion. And I couldn't be more honored, humbled, and encouraged about the future success of where we're all headed. Again, thank you to everyone out there for everything that you do. I look forward to working with each and every one of you as we move forward. So thank you for your time. Appreciate it. Nate, I'll turn it back over to you.
Super, Brian, thanks so much. I'm looking forward to working with you. I think it's interesting in your video for us to think about what those other use cases might be out there if you eventually were able to drive down the cost of vertical takeoff and landing. So that's very helpful. Thanks for the partnership, and looking forward to working with you.
Absolutely.
As we transition over next, again, one of the core reasons for us to team up over this last couple of days is to find those opportunities where universities are reaching out with the small businesses that are out there to make sure that there's a transition path for the fantastic research that is happening. And with us today, leading this next panel, is Dennis Andresh of the Wright State Applied Research Corporation. He's the CEO. He's been doing fantastic things on creating these partnerships over a long period. And today he has a great panel laid out to talk about what we do across this industry to team up and move this technology from research institutions eventually to the skies above us. Dennis, thanks for being here. and welcome to our Agility Prime team up.
Colonel Diller, thank you. Thank you for this opportunity, and Dr. Roper too, for the vision of doing Agility Prime, because it really is going to change, I believe, the aerospace industry for the long term, and it's critical for the future. And it's all about partnerships, as you said. It's developing the workforce as well as the supply chain to support these platforms as they're developed and fielded and so forth. So we look forward to the panel today. So let me introduce some of the panel members that we've got today. We've put together an excellent panel all the way across the country. The first panel member is Professor Alex Band, from the Director of Institute of Transportation Studies at UC Berkeley. He actually is a professor of engineering at Berkeley. He's also research faculty at Lawrence Berkeley National Laboratories, expertise in robotics, intelligent systems, artificial intelligence, as well as cyber physical systems, which is actually a critical area for these types of systems. So Dr. Band, thank you for being with us here today. Next, I'd like to introduce General Bartman. General Bartman is with Ohio State University. He's the former Adjutant General of the Ohio National Guard in Ohio, served that role for multiple years. He's a graduate of Ohio State, so he's back at his alma mater supporting them. I've actually worked with General Bartman over the last 5 or 6 years here in Ohio. He's also a command pilot. He's got 3,200 flying hours, so he knows about flying and what that means. And his role at Ohio State is to help faculty connect to businesses and assist in the transition and develop those collaborations with industry, as we talk about here today. Next, we've got Dr. Talinda Larson. Talinda is with the Utah Advanced Materials and Manufacturing Initiative out of Salt Lake City. She's also the CEO, I believe, of Skylark Drone Research. She's done a lot of work in urban air mobility, has done a lot of work in improving operational flight in airports and so forth. She's worked with the Department of Transportation, and she's also a pilot and has got experience in flying. And so lastly, we've got Dr. Dada from the University of Maryland. He's a professor in engineering there, aerospace engineering, oversees the vertical lift centers of excellence in Maryland. Has a lot of research in eVTOL, high-speed tilt rotors. He's also worked with the Army Aviation Development Center, NASA Ames Research Center, and has actually led development groups in the commercial air mobility areas. As you can see here today, we've got a very robust panel and experienced panel to support the discussion. So what I'd like to do is start from the top and have Professor Bayan talk about his work, his organization, and maybe address from his perspective, what are the research thrusts that Agility Prime needs to address to make these operational systems. Dr. Bayan, over to you.
Yes, thank you. Hopefully people can hear me fine. Just want to express my warmest thanks to Colonel Diller for the invitation, and to Associate Dean Carl von Weber for making this panel possible for me. In the preparation for the panel, one of the things that I discussed with some of the people was the assets that universities can bring to the table and how they team up best to the SBIR STTR program, which will be my first point. And then in the second part, I'll tell you a little bit about one of the thrusts that Berkeley is pushing under Associate Dean von Weber's leadership in that space. So I think what makes Agility Prime really helpful and really beneficial is that this brokering mechanism between academia and industry is quite spectacular. And it's particularly successful when interests are matched, which from an academic perspective can mean early access to data, early access to facilities, or to even faster implementation that we might not do in academia. Now, on the industry side, I think what's interesting, for industry partners when teaming up with us, is the same in a different way. Academia has a lot of facilities that enable potentially companies to move faster. Research and development teams that might not be possible in the early existence of a startup, and potential access to investors, which are different from the private sector. And so I think when the confluence of the two happens really nicely when incubators make that possible. And for example, at Berkeley, Skydeck is such a good example of this, in which these two ecosystems have really nicely partnered together. To conclude on that very first point, I think one of the things which is particularly interesting with the audience that is here today is the fact that the STTR program, and to a certain extent the SBIR program, provide really good opportunities, and Berkeley has really benefited a lot from these programs over the last years. One thing which is key to realize is the notion of timeline. Some segments of industry move very fast because of the market, and in that context, maybe a phase 1, phase 2 approach, which has a 6-month review period, sometimes doesn't match the market. But in some cases, like we heard in the earlier panels, where the development of infrastructure, and it's kind of the case with Airspace, makes it to much longer time scale, I think that make that partnership really beneficial. And so I think that's kind of a good segue into the second point I wanted to give briefly before I hand it over to the next panelist, is one of the things that we're really interested in at Berkeley is to advance the state of urban air flight. And we heard from the plenary speaker, Sebastian Thrun, the absolutely amazing vision about a form of decentralization of air travel with smaller vehicles in a completely new paradigm that he has described in the plenary. And so that's a really good introduction to one of the thrusts that Berkeley wants to pursue and that we've started to plan for, which will take several years, but for which Agility Prime could provide a really nice framework for us. So as you know, Berkeley has several campuses, the main campus, the Richmond Field Station, and has a recent interest to get closer to NASA Ames and Moffett Field. As part of the UC system, we have sister campuses in San Francisco with UCSF, UC Davis, and Santa Cruz. And one of the interests that we have at Berkeley is to pioneer an airlink between these different assets of land we have. And we've seen the emanation of air travel for urban flight with Blade, with Uber Elevate, and a few other commercial entities who have already pioneered this. What we just heard from Sebastian Thrun is a very different model where people are going to move away from conventional helicopters and move into electric propulsion with smaller engines. And that's one of the things that we would love today with this broad audience at Agility Prime, see how we can get the private sector interested in teaming up with government agencies as well as academia. We think that over the next 10 years, we will see air travel, inter-campus travel by air in ways that has never been done before. And we think that the Bay Area, because of its geography, the water, and the different assets we have, will be probably one of the first places in the US where this becomes a reality. And so today, the end of what I wanted to talk about is really an invitation for all the stakeholders who are listening today, the startups that have joined Agility Prime's event today, the government agencies, and academia, to engage with us in trying to understand how we're going to build an implementation plan so we can make air travel a reality in California over the next 10 years as a prototype living lab, in a sense that will connect the main campus of Berkeley with other entities. And to finish, I want to point to the rich tradition that UC Berkeley has had over the last many decades in creating such test beds. Some might not remember, but 30 years ago, Berkeley was already running self-driving car experiments in Southern California on I-15 in a test bed that we built. More recently, there have been other test beds that have been built together with public agencies and the help of the private sector. And so we really hope that tomorrow, with the help of all of you, we will be able to together plan this living lab of an airlink between the Berkeley campus, our other sister unit UC campuses, and potentially other networks as one of the first corridors for urban flight, for which we have heard such a nice paradigm depiction in the previous talk. I'm going to stop here because I think we have a lot of panelists, but I want to thank again Colonel Diller and Associate Dean Carl von Bibber for the opportunity, and definitely look forward to engaging fruitful discussions with all of you. Thank you.
Dr. Bayan, thank you. Having lived in LA, I look forward to be able to commute a lot better than I used to commute the 405, which was not fun. So totally understand. So next up, Major General Bartman at Ohio State. if you could give a little background of the work at Ohio State and what you see as the biggest challenge research area for agility.
Thanks, Dennis. I appreciate it. I always enjoy listening to Sebastian talk. I met him the first time about 5 years ago when my previous boss, Governor John Kasich at that time, brought him to Ohio to talk about workforce development, which Colonel Diller mentioned. He was one of the co-founders of Udacity. So it was exciting to hear some of the things that he's doing now. So as Dennis mentioned, I am a retired Major General from the United States Air Force and Ohio National Guard. Spent many years flying mostly F-16s during my time in the Air Force. I currently am the program executive now at Ohio State for two very important programs. One that has been going on for about 5 years, which is called the Ohio Federal Research Network. And that is primarily state-centric because it's funded by the state of Ohio for technology push-pull into and out of our academia and with the military and small business here in the state. And then the other program, which was highlighted yesterday, which is called APEX, which is the Academic Partnership Engagement Experiment, which is funded by the Air Force. And that is a nationwide effort to do basically essentially what OFORN has done over these last 5 years now on a national level, and that's try to engage the small business with higher education to further develop a lot of this technology that otherwise would probably not get out of either the research institutions, laboratories, or our national labs. So I'm really excited about being able to do some of those types of work here. And this opportunity, by the way, that Agility Prime has given has been really off the charts, in my opinion. Just over the last week, and especially yesterday and today, I've probably made contact with about 30 or so small businesses that are interested in wanting to see if they can partner with some of the talented faculty that we have here at Ohio State. And I will mention that we, being one of the largest research institutions in the country, Ohio State had expenditures in research that was approached $1 billion last year. So there are a lot of things going on that we do here that we'd love to partner with. You mentioned the Agility Prime research area, and I know there's a fairly lengthy list of things that are important to do. I'll highlight, though, that this morning as I was looking at the news, I happened to see that the UK and their primary next-gen fighter aircraft manufacturer, BAE, is looking at a way to do electric propulsion for their fighter. And the Air Force, of course, is working on what they call NGAD, Next Generation Air Dominance aircraft. And I'm sure that there's somebody within the labs inside the Air Force that's thinking about, potentially something like electric propulsion for that aircraft as well. So I'm sure that that's probably one of those things. There's obviously other areas, autonomy, which is a big opportunity, supply chain security, which is not necessarily always mentioned, but I can guarantee you as a former fighter pilot and somebody that spent an awful lot of years in the military, I would really like to know for sure that if I'm dropping a bomb or shooting a missile, that when I hit that pickle button, that it's going to work like it's supposed to. So those are some things I'm sure that a lot of people are interested in wanting to help out the Department of Defense with. So I'll stop there just to keep it short, and I'll turn it back over to you for now, Dennis. Thanks.
Thanks, General Bartman. So actually a little bit example on OFRN, we actually required, state funded this, we required a lead university, a partner university, and a small business and a federal partner. And in one particular case, the university didn't know about some capabilities in another university in the state. And actually the business accelerated its product by about 3 years by forcing the partnership to collaboration, which is really the topic here today of research and collaboration is really what we're trying to drive to. So next, speaking of collaboration, is Dr. Talinda Larson from the Utah Advanced Manufacturing Institute and Materials Manufacturing Institute, sorry. I've got your slides, and so I'll project those for you, Dr. Larson, and turn it over to you.
Thank you so much. My appreciation to Colonel Diller for including UAMI in this very important discussion. And yes, if you would put up my slides. Thank you so much, Dennis.
Are they good?
Okay.
Can you
So
see them?
I can't see them, right, as a speaker, but I can watch them.
Yeah.
That's okay. So let me start off with what is UAMI, Utah's Advanced Material and Manufacturing Institute. We are a public-private partnership based in Utah with the mission to promote and expand Utah's advanced material and manufacturing industry, which represents more than 200 companies in our state. In essence, UAMI is a convener, or as we're calling here, an enabler between industry and the research institutions to support many types of manufacturing, commercial manufacturing, including medical and recreational vehicles such as skis and bicycles. But our primary support is with the defense manufacturing. With the
Sorry to interrupt for just a minute, but whoever has the slides, if we could go ahead and maybe make those a little bit larger. I don't think they're projecting quite right there.
Thank you.
Sorry about that. Mark, I don't know if you can help
That
us.
was Sterling, Nate.
Okay, thanks, Sterling. If you just go to project.
You got them, Sterling?
They look like they're in
Funny mode.
yeah, maybe try down at the bottom in presentation mode. There we go. Oh, that's my last slide. But go, so if you can go
Thanks,
back,
Sterling.
keep going. There we go. Okay. So, so our mission is again to support commercial industry, aerospace, but our primary focus in the state of Utah is supporting defense manufacturing with the purpose of strengthening the defense industrial base and providing support to the warfighter. We are focused on 4 primary areas: workforce development, small businesses in manufacturing through a grant, through a program that we administer on behalf of the Small Business Administration, known as the Regional Innovation Clusters Program. Supply chain resiliency with a software product that we've developed in the state now is spreading out throughout the nation called Connects, and fostering research. Next slide, please. So I thought I'd take a step back because this is a very narrowly focused discussion area for Agility Prime, because it is essential that if we are going to get these aircraft to certification and then into production, they're all assuming that they're going to have all this new technology, but these new technologies have not yet been tested and qualified for aerospace. And what are we talking about specifically? So if you look specifically at what is an advanced material, primarily right now it's composites and carbon fiber, but it's also plastics, graphene and nanoparticles, ceramics, and also advanced fuels such as hydrogen. And then the second part of UAMI is advanced manufacturing, or Industry 4.0. And that includes 3D printing with additive manufacturing, processes used for composites and making them into carbon fiber, using 5G as applications to manufacturing, looking at advanced processes that are better for the environment, and increasing professional and production services. Next slide. So I have 2 examples here for our discussion today, or just as what UAMI does. UAMI does not do the research ourselves. Again, as I said in the beginning, we are conveners. We are enablers to bring together industry and research in the state of Utah, and also with our defense community there. One of the programs that I find super exciting is what we call coal to carbon fiber, or C2CF, where we're taking coal, which of course has a lot of issues in our economy and our nation, and because of its issues with environmental and the market for coal as energy. With a carbon fiber product that is a third of the cost of producing carbon fiber today. So we have a grant with the EDA and led by the University of Utah, working with the University of Kentucky and UAMI. And we have now successfully taken pitch and spun it into fiber. So now our next step is to scale it up and to make it a viable commercial product that can be used in orb aircraft. Next slide. A second project that we facilitated and convened and got industry together with research was the use of 3D carbon printing. This is a machine that's pictured here, is manufactured by a private company, Impossible Objects, and it's called a CBAM machine, which stands for Carbon-Based Additive Manufacturing. It's a program that we are working with America Makes and Air Force Research Lab to use this new process that infuses carbon fiber into the 3D printing for the Air Force sustainment programs. We're printing parts for legacy aircraft. Right now they're non-flight parts, but we're proving that the technology is such that we are able to create these parts that are not available anymore and be able to have a equal strength to a metal product by infusing the carbon into the 3D printing. We've now turned our efforts to support urban air mobility or AAM, whatever you want to call it. Oh, that's not me. This is my last slide. We're by working with Electrifly, which is a single person urban air mobility, air taxi, flying motorcycle. We have started to produce with Impossible Objects a research project of making these 3D printed carbon-based parts for their aircraft, which will be reducing the weight so they can get the test aircraft under the 55-pound limits and be able to test the aircraft without a person on it, but test the aircraft nonetheless under the Part 107 rules and regulations, which are far easier to get your testing of the flight characteristics. So those are just two examples of what we're doing in Utah and how UAMI has been able to enable the research institutions and industry to work together. And at the risk of offending, my opinion is the STTR is the perfect vehicle to move forward the technologies that we need to launch and be able to get into development these aircraft and into certification and commercialization. And the reason is because small businesses, all businesses, are incentivized to survive. They are incentivized to reach profitability. So for small businesses, the objective is faster, the better. Whereas research institutions, their goal is to research and they optimize research dollars. So combining the deep technical expertise of research institutions with the fast, agile, innovative processes of small business, I think is so essential to being able to move forward with particularly using advanced materials and advanced manufacturing techniques. Thank you very much.
Dennis, you're on mute.
Yeah, Dr. Larson, thank you. And I agree with you on the STTR. We had a small business that was out of the University of Illinois, and we used STTRs to leapfrog other competitors. We eventually sold the business, but the STTR was critical for accelerating the technology transition out of the university. So totally agree with you. Next up, we've got Dr. Dada from the University of Maryland for the Vertical Lift Research Center of Excellence. And Sterling, if you wouldn't mind projecting his slides too.
Right. So more important than who I am, I want to put in some information that could be of use to the government as well as the companies. So there are 3 vertical lift centers of excellence in academia. I am from Maryland, Georgia Tech, Penn State are the other two. But these are not just 3 schools. It's a formation of 15 schools over 10 states that for 40 years have provided sustained long-term strategic workforce in vertical lift. The centers were created by the Army. They're essentially Army supported centers, but today Navy and NASA are equally important partners. So all of us hope that one day we'll also have Air Force engaged in this program. If you want to know what is the output of research from these centers, what they have been doing, the best place is to go to VFS. If you go to the next slide. So VFS is what used to be called American Helicopter Society. This is where Igor Sikorsky, Bell, Boeing, all the pioneers you can think of started publishing. So there is a journal, there are 3 major forums. These are technical forums. And so you can track the work that is being done by all these institutions and everybody else. So this is bona fide, authentic information, which is very important for disruptive technologies that are trying to grow. Coming back to the centers, next slide, please. So the centers, and all centers, I'm just showing slides for Maryland, but what I'm going to say is equally applicable to all. They have critical mass of vertical lift faculty, very unique facilities, unique tool sets, and a structured curriculum, which is used to prepare the students to break barriers of national importance. And as part of the curriculum, many of those courses are also offered as professional masters, something for the companies to keep in mind. So anything from micro air vehicles to the helicopter that will fly on Mars next year has a connection to the vertical lift centers of excellence. So these are the people who know how vertical lift work. Next slide, please. So I talked about preparing students for barriers of national importance, and they have been driven by DoD and NASA. That has always been our focus. eVTOL is such a problem. Power is the principal barrier. Power, power, power. Everything else is a distraction. What is very special and particular to vertical lift, what 80 years of vertical lift has taught us, is it's very intimately connected to platform. You cannot separate power from platform like you can do in cars, in fixed-wing airplanes, or even submarines. So power and platform must go hand in hand together. If you do it in an isolated way, you're doomed to failure. A demo is one thing, but a practical aircraft needs much more than demo capabilities. And I'm sure no one understands that better than Air Force. So I'm very glad, we are all very glad the Air Force is investing across the spectrum, not only in some special purpose areas. And we are very eagerly looking forward to see the program grow and flourish. So I'll end it with that.
Thank you, Professor Donat. So one question for you is, what's the best method for a small business to connect to these centers, to work with these universities as partners, like on the STTR program? How would they best connect to these 3 centers?
So of course, the mechanism of connection is known to all. I would say number 1, visit the labs, which of course is out of question now, but do your due diligence. There are now 100 companies chasing 100 different faculty. You don't know what is real. Visiting the lab or even talking to them makes a big difference. Number 2, don't get into ITAR, and that has nothing to do with international students. Without peer review, there is no progress. So don't get into ITAR, at least in phase 1 and phase 2. Number 3, in terms of approach, what we have found, or at least I have found and many others, imagine you are training the student you want to hire in 2 years. That's the best way to approach a university.
Very good. Excellent. Dr. Bain, how about you? What do you think is the best method to connect to the University of California, Berkeley network?
I mean, I think in addition to the previous ones, I think one of the things which makes Berkeley so special is the span of incubation we have, which goes from inception. At Berkeley, within the College of Engineering, there's an institute called Citrus, which has something called the Foundry, where technology is invented. That further gets migrated through accelerator programs, such as the Bakar Fellows Program, the Signatures Program. Then Skydeck is our first outward-facing incubator, still run by the college. And then around that, there is a second layer of incubators like the House, which are not run by Berkeley. So I think for companies to engage, I think finding the right place of connection through that different pipeline, whether, like we just heard, directly in the lab to companies that is already launched but could potentially team up or partner with. And I think, again, there's no obviously single shoe fits at all, just because companies are so different. But I also agree with the fact that the STTR program is great, and the connection is great, and it really needs to be carefully matched with the timelines. Again, for some technologies, a 6-month review plus a phase 1 successfully leading to a submission to a phase 2, with another 6 months review and a 40% success rate leading to potentially much longer grant, could be way too fast or way too slow. And so I think there is also that aspect that has to be taken into consideration.
On the timing, good point, very good point. And you got to fit to the academic cycle to some extent too.
That too.
Yes. Dr. Larson, how about you? From UAMY's perspective, how would small businesses best connect through your UAMY into the universities?
Well, fortunately, again, the role of UAMY is to have an outreach program through the Small Business Administration research regional innovation clusters, where on a daily basis we are going out and talking with the small businesses about their technologies and assessing their needs. That's one side. Then on the other side, we are working with our key academic institutes, as I said, University of Utah on the coal to carbon fiber, but also BYU, Utah State University, Weber State. We have a real center of excellence within Utah on composites, where 85% of the nation's composite materials are manufactured in Utah. So the best way is through the matchmaking that UAMY has been doing. And then in our Governor's Office of Economic Development, they have a program through their Innovation Center that helps small businesses to get through the process of STTR. So that combination has been proven very successful in Utah.
Very good, thank you. General Bartman, you said you've talked about 20 or 30 companies in the last couple of days. How are you making the matchmaking there, working at Ohio State?
Thanks, Dennis, for the question. So there's a number of different ways we can do it. Dr. Van alluded to some things that we do something similar here at Ohio State. We have what we call a corporate engagement office. There's a technology commercialization office. There's an industry liaison office. And then within the College of Engineering, there's also several research organizations that can connect to small businesses. The position that I'm in, I'm kind of fortunate because I actually get to float amongst all of those. So I connect all of those different individuals and organizations to small business, as well as to the faculty that are here at Ohio State. So as you mentioned, the businesses that I've talked with here in the last couple of days are ones that now I will go into the university and find faculty that are doing research that is similar, or maybe even hasn't been done yet, but has faculty that are interested in doing that kind of research. And one of the unique things I think that the university can bring is, and that the faculty brings typically, is going to be students, right? So innovation and agility is key a lot of times when it comes to the developing and doing research. And I know that Ohio State doesn't hold all of the key to having incredibly bright students. That's all across this country. So every university has students that are going to be able to help out in these kind of initiatives. And so, finding that business and then finding that faculty that are willing to partner up and work together and then having the faculty be able to bring graduate assistants, research assistants, those kind of individuals, also to being able to bring them together, I think is really key.
Thanks, General Bartman. So next, Dr. Larson, what's the best practices that you've seen in getting university, industry, government partnerships going from your perspective? You're kind of unique because you're trying to bridge all the gaps. What's the best practices that you've learned to make that work?
Well, some of the best practices just include collaboration and having opportunities to exchange ideas. We have UAMI hosts. Historically, we've hosted twice a year what we call crosstalk, where we bring in industry and research and the governmental entities to talk about what are the leading technologies that are coming out, what are the research needs. We're hoping, well, our March obviously did not occur. We're still holding strong that we'll be able to hold our November 19th crosstalk event, where we have both national participant speakers sharing ideas and working with our, what we call in Utah, our national lab at Idaho National Labs, to help talk through what are the research needs and then matching them. One of the nice things about Utah is that it is a hidden jewel in the United States because of the really deep research that does occur at our universities, but focus very much with University of Utah, BYU, Utah State University, and our other supporting universities. That's very accessible. So I think the best practice is to foster these collaborative meetings where the participants can face-to-face, or in these days, Zoom together, and have an opportunity to find out what their needs are as far as research. We have a program we call RAMP, which is Rapid Accelerated Manufacturing Program, which is a mentoring program where we go in and we work with these small manufacturing. We're all about manufacturing and, of course, advanced materials and advanced manufacturing, given our name. So when we're in there doing RAMP, we're able to very much be able to find out where there are needs for research to be further developed, and then we match them up with the research institutions that seem to be most applicable. And then we go after STTRs, SBIRs, and other grants and other programs to support those initiatives.
Very good. It's a process that you have to walk hand in hand together on, that's for sure. So.
And just a lot of talking, a lot of meetings.
Yes.
A lot of sharing.
Yes, thank you. Professor Dowda, how about those 3 centers of excellence? What's the best way to interact there and the lessons learned you've learned in those 3 centers of excellence working with them?
Yeah, this is a very important issue. I'm happy you bring this up. VLARCO does it in a very special way. So all the academic participants are not encouraged, but mandated, forced to talk to the industry and pick up topics that the industry believes has a long-term, 10 years, 15 years, 20 years, or short-term, on a case-by-case basis, impact on their business, so that we are not stuck with academic dead ends that can't be scaled out. So it's still very basic research, but it cannot be baseless. The reason it's very important is that the US government have started defining basic research so narrowly over the last 10, 20 years that almost borders on baseless. To give you an example, we can build tiny coin cells, 30 milliamp hours, publish wonderful papers, and give each other awards, and then go home. All of those many of those can never be scaled out. So that's why it's very important for industry to actively participate in the beginning, to down select from your fundamental ideas some that you think you can champion to scale out. So that's how it's done in the VLARCO. And so far it has been great because they're the ones who are hiring all the students 5 years.
We did something interesting across Ohio. We used the NSF I-Core, a variant of it, to run the teams through the I-Corps program, which forced them to talk to end users of the technology. And it was amazing. The quality of the product that we ended up with was far better than some of the other approaches that we used. So it's really critical to interact with the end user, they're the industry partner that's going to consume the technology. So thank you. Dr. Ban, you mentioned your university's benefit from STTRs. What's your recommendation, and how's it worked at your university, and how's it benefited the university on the STTRs?
Sorry, I didn't quite hear the last part of the question. How does it work on the what?
How did it benefit the university, and how did the university benefit from the STTR program?
Right. Yeah, we alluded to this a little bit at the beginning. So certainly, from an academic standpoint, and I was very clearly pointed out by Dr. Larson earlier, the timescales of research might be very different from the timescales to go to market strategy or even market discovery. So I think the key in that happy matchmaking is to find a way that the interest from academia can be matched. And a few examples include so access to data. So obviously, academia develops technology, but does not always have the ability to deploy it as fast as the private sector. So data is definitely one of them. Speed of implementation, because if you think about doctoral programs, the goal is to advance science, technology, not necessarily to do implementation. So that is something which is a very happy matchmaking component. And access to facilities, ultimately, when maybe a startup grows from a seed round to series A or B and starts to grow. The other side of this happy marriage is the things that a small business or a startup cannot afford, such as a research lab. So if you think about research which requires access to very expensive capabilities, such as wet labs or MRI or very heavy instrumentation infrastructure, clearly these baby steps of a company can still be walked in a university lab in a way that accelerates their development. And then the access to specific funders that they might not, and the ones I'm specifically thinking about is government agencies. For example, sometimes it's much harder to bid on a state contract or a federal contract if you're a company than if you're a university. And in the case of Berkeley, because we're a state university with a very special relationship with all our state agencies, we can use interagency funding transfer agreements, which are a great accelerator to funding. So this is potential components to a happy marriage. So I think it's really a bilateral street here in that academia has to find the right things that make sense for them in these companies, given the differences in timelines, processes, and funding access resources. And then the private sector has to find the right assets in academia that make it work, because as we heard, sometimes the processes can be a bit hard administratively, time-wise, and with other aspects of these partnerships.
Thank you. Laboratories and facilities are critical, and there's a lot of laboratory capabilities across the universities that could be leveraged, as you said, and that relationship is critical. So it looks like we're getting close to the end here. So I want to thank the panel for all the answers and describing your backgrounds. The good news is we covered the country, East Coast to West Coast, as well as the middle of the country. And so I appreciate all your time today. So I'll turn it back to Colonel Diller.
Super, thanks a lot. Thanks to all the fantastic panelists. It's great to see really all of the research institutions that are being very aggressive about getting into this domain. In terms of partnerships, one of the fantastic partners that we have had in Agility Prime has been NASA throughout, and it takes no introduction for someone who has frequent flyer miles on our Agility Prime ship here. PK from the NASA Aeronautics Research Institute is here to finish off this team up event, bringing in a panel as we talk to supply chain. And so we went through and spent some time thinking about what is this workforce of the future look like? How do we make sure that we're integrating into the universities and looking in ways to make sure that we've got our future engineers understanding and looking at this segment. What are the things now, PK, that we need to do to make sure that we have that industrial base, that supply chain that's ready to go? Excited to hear thoughts from you and those on your panel, and excited to continue this fantastic partnership that we have with NASA over to you, and thanks for being here this afternoon.
Thank you so much, Nate. I hope everybody can hear me all right. Great, perfect. Thank you, and appreciate your friendship and the relationship we have between NASA and and Agility Prime. So it's great to see that and continuing, and we're very happy to work with you and happy to support your efforts, Nate. So thank you for your leadership there. We have an extremely well talented panel that includes Steve Bradford, who is Chief Scientist of FIA's Next Gen, and he has a lot of tremendous accomplishments, such as SWIM, UTM, and enhanced upper airspace class E traffic management, to name a few. Then we have Star Jen, who is the chief and lead of NASA's national campaign that supports the eVTOL industry and pushes forward the state of the art. We also have Dana Jensen, my good friend, who is focused on supply chain and economics related to advanced air mobility and eVTOLs. And I personally am very passionate about supply chain management issues and opportunities to build a robust and resilient supply chain related to the emerging industry, eVTOL, as well as the drones and supersonic, hypersonic, and aerospace industry of the future. So we are going to kickstart with a number of things that are related to supply chain. You heard a lot from the university distinguished colleagues about the supply chain in terms of the talent. There is a supply chain issues related to the manufacturing. There is supply chain issues related to the infrastructure and the research, and there are supply chain and items related to testing. So we're going to talk about all these issues together collectively. So we're going to start off with research first, so that we make sure that the research is supporting the future needs. And our distinguished guest here is Steve Bradford, who is the chief scientist. So Steve, I would like to request you to offer remarks for about 5 minutes or so.
I'll unmute myself. I'm gonna hurry up and share something I threw together today. Just Pete asked me to talk about where we think we're going with eVTOL in terms of operations. So so I'll start my video. I'm in the basement, but okay. I just put a quick concept look at where we think urban air mobility, which is sort of the target for eVTOLs, will go. Let me go to screen. So basically, we all know this. We're going to leverage what we've learned about urban UAS traffic management, which is our way of managing small UASs 400 feet and below. If you're familiar at all with the way we do flight operations, we have VFR where the pilots cooperate with each other to separate based on a set of rules. We have IFR where controllers get involved. Small UASs are in a world where controllers don't get involved, but because they don't have eyeballs, they have to replace what you would get visually with a set of information. So we've come up with what we call UTM, which have community-based rules. We think the same thing is going to be important for UAM and eVTOLs, because you can fly in air traffic system with air traffic controllers, but the tempo that people want to fly and where they want to fly would say they'd have to be what we call instrument flight rules. They'd have to be directly controlled by controllers. So we're looking at how can we do this without involving controllers, because a controller can handle up to 25 aircraft at a time, and this whole population would like to have several hundred operating in a terminal at the same time. So we're trying to set up an environment. We're looking at possibilities where the operators will be responsible for maintaining separation when within a corridor system. This is a picture of the corridors, and I'm going really fast because I've only got a couple minutes. The eVTOLs, the UAM operations would be in here, and we'd expect a higher performance than you would have in a normal operation because of the density of the operation. And we think they would go from known vertiports to known vertiports as opposed to airport to airport, traditional airports. The key here is that there has got to be third parties providing services to them. For UAS, as we call them, UAS service suppliers, just because it's not necessarily the case that a UAS service supplier for a small UAS would also support UAM, we're calling them PSUs. But basically, this will involve a shared network, which is federated. We believe the communications for the people operating in this network would be third party. The weather, unless they would be, depending on the height they want to fly, would be third party. It wouldn't be necessarily provided by air traffic specialists giving you information. And it's all based on vehicle to vehicle sharing intent data and position and intent data so that you can strategically deconflict. And there'll have to be a vehicle to vehicle component here. And this was probably could not be done. I'm going to go. Here's our architecture, which basically says the FAA has a thin architecture and the whole world provides the rest of the architecture. So if you got supply chain for the vehicles, you also have a whole supply chain issue here for the operations. Jumping ahead, this is where we see it going. So early on, you'll fly like anybody else. You probably have a pilot on board. You'll probably operate just like any other IFR aircraft, and you will involve ATC. At some point, the tempo, the separation between the vehicles will have to be more limited. We'll have to go in the corridors, and we consider this human over the loop, where there'll be more and more advisory services supporting the pilot, because the pilot will probably be not able to maintain the separation at the tempo and the density that you want. It'll have to be assisted. And at some point, 15 years from now, if the density goes so high in urban areas, we'd have human over the loop. So the idea is that, yep, you'll have vehicles who can operate kind of like helicopter, but the manner in which they operate will have to evolve if you want to meet the urban air mobility targets. And we will have to evolve the airspace and the manner in which you work together so that we can meet this need. So we will, one last thought, we will accommodate you in the air traffic system. Like I said before, every controller can only handle 25 to 30 aircraft. In a terminal area, you might have 10 to 15 positions, and that means that you would then go into a demand along with all the other traffic for service, and we would probably limit your access to the airspace. So it is key that the industry figure out with us how they can operate safely outside the ATC system. And with that, PK, I'm going to let you get into your supply chain. Unless you have a question.
Thank you, Steve. No, that's great. Thank you.
And we can provide these slides if they want them.
Okay, yeah, that will be great. Thank you. We will be happy to share the slides. That's a great offer, Steve. So next speaker, let's given that what Steve mentioned about the research and such. So as part of the chain is also making sure that the testing is done and we have data to support the decisions that are made. So may I request Star, who is the lead of the national campaign at NASA, to articulate her thoughts on how the national campaign is working out and what are the things to look forward to in the next chain of events.
Thanks, PK.
Star,
Can you
could
hear me?
Please, yes, thank you.
Okay, great. Hello, everybody. So super excited to be talking to you at the Agility Prime panel. And I have a little bit of supply chain experience in the development of X-57. That was one of the projects that Mark Moore and I and Sean Clark pitched to NASA and got a X-plane. So, but what's really hard is you have very small, very few small businesses that are actually manufacturing the distributed electric propulsion hardware. And typically the background of those small businesses is not from an aerospace community background. And so, understanding the vulnerabilities of cybersecurity on any kind of software that's built, like say in motor controllers or battery management systems, trying to get motor controllers through environmental testing has been a lot of work and a lot of redesign. So it's nice to have these new players, certainly working the eVTOL or UAM or AAM, whichever bucket you want to put them in. But we really need to start thinking about the robustness and the quality assurance and the rigor that goes into everything from where your supply chain's getting their components and the quality at which they're building it. But national campaign. So NASA's taken on lots of different pieces of the advanced air mobility problem space in our research. And national campaign is focused on collecting operational data so that we can basically create this new aviation market. And so as Brad was saying, a big component of that research is going to be creating an airspace system that is no voice comm for the most part between an operator, air service operator, and for this initial step, a pilot on board. And obviously we need to have we're going to be evaluating really where we do need to engage with ATC as we're looking at contingencies during some internal terminal base operations or at any point at which the vehicles that are trying to fly densely spaced together are going to interfere with existing national airspace traffic. So we're gonna start looking at that. We're developing safety scenarios, and we have hundreds of parameters and requirements that we've received from the FAA of areas that they need to evaluate if there's gaps in their current standards that need to be reconsidered. So we're taking a anchor and evolve kind of approach in this beginning of the national campaign to do the crawl, walk, run with the FAA to integrate this operation in the current national airspace. And when I say anchor and evolve, it means we're going to look at the certain set of standards, the standards that are there right now, and how many of them these particular vehicles and their stability and control and performance can manage the current standards, and where we might need to make infrastructure changes, where a helipad circular is too restrictive and we need to start thinking about a vertipad, for instance, and what would go into that. Looking at performance-based routes, so they have limited energy storage on board for a lot of them, and so how do we come up with tight volumes that they are flying in within their aircraft management, their fleet management, how we reduce the more of like the automated flight management system to be able to do route following and compliance in tighter areas than current flight management systems or autopilots can do. And obviously there's a bunch of more infrastructure like communication, navigation, surveillance we have to start evaluating of how we constantly have that messaging capability to the vehicle that's in the air and getting the right situational awareness at the right time that they need it. Whether, how do we reduce the amount of weather infrastructure? How do we get ourselves to where we could do like, an IFR path all the way to the ground for a helicopter, which really doesn't exist today. So there's lots of empirical data that we are going to be gathering. First, we're going to do it with helicopter, just to test out the NASA flight test infrastructure and our safety scenarios and flight test plans with the FAA. And then our first partner we'll be working with is Joby Aviation, and we'll fly with them in the springtime and get to assess, real eVTOL performance characteristics in some of the solution space that we're considering. And we will have an announcement for collaboration for our first national campaign coming out January of 2021. Any companies right now who have vehicles that are, I would say, starting to go through envelope expansion, that's the readiness level that we're looking at right now. We just reissued our information exchange to kind of prepare a roadmap of how we can partner with your company, your vehicle company, in preparations for NC1. So that's latest status from my side. I'll hand it back over to you, PK.
Thank you. Thank you, Star. As you can see, NASA has many stars, and Star Jin is one of them. So our next speaker is Dana Jensen, who is a good friend of mine, and he is working with me together on aerospace supply chain, assuring the robust and resilient supply chain and manufacturing capabilities to support the eVTOL and its scalability over a period of time, but including what happens today from the entire life cycle from design to high scale. So with that, I would like to welcome Dana. Dana, maybe you can start off with the announcement of our supply chain working group and how people can register, and then go into the details of our priorities. Thank you, Dana.
Absolutely. First of all, thank you, PK, for hosting this, and thank you and congratulations to Colonel Diller and the whole AFWorks team for pulling off yet another extremely successful online event. You're batting 1,000 at this point. As PK mentioned, I'm from the Air Force's Office of Commercial and Economic Analysis. We are partnered with AFWorks to work on Agility Prime, looking at the use cases, getting technical insight into the enabling technology involved, and also looking at the ecosystem, right? And so, PK and I have been collaborating very closely on what our approach ought to be to looking at the ecosystem, and we've settled on, I think, at least 3 lines of effort. One is related to talent, right? And I think that's been discussed earlier today, so I won't belabor that. One is related to understanding what the supply chain is today, both current suppliers to OEMs and aspiring suppliers. And then another is built toward kind of modeling and simulating the scalability of that supply chain. So, if you're a manufacturer today and someone comes walking into your hangar with a checkbook and says, "These are great, I'll take 5,000 of them," can we do that, right? And so that's what the NASA is taking the lead on that aspect of things. And so really the key is I kind of want to explain what it is we're doing with the ecosystem and how we're gathering data, because I know that a lot of you out there are current or potential suppliers, and you're being asked for information. You submit to the showcase or at the earlier kickoff event, and now there's an RFI that NASA put out asking for similar information. And I just want to kind of explain that that's the data that's going to feed our analysis, both the modeling and simulation piece, and also kind of understanding the current laydown. So I highly encourage anyone there who's contemplating or is involved to please be as forthcoming as you're comfortable with in replying to the RFI or with the questions that are involved with becoming part of the ecosystem, because that really is what's going to drive our view, right? Because this is an emerging supply chain. There is no existing data set. I mean, there are some commercial data sets that have looked at eVTOL, and we'll certainly entertain those. But realistically, it's an emerging ecosystem, right? And so in some ways, that's a big opportunity because, if you talk to the big primes, and ask them about supply chain. They have teams of people who are trying to understand, several tiers down what their supply chain looks like. It's a mature industry with a very complex supply chain. And in some ways, we have a real opportunity here to understand and get our arms around the eVTOL supply chain from the outset, right, with this emerging technology. So that's great, right? I'm excited about that fact. But it also means that, we tend to have to kind of crowdsource the data. So, we really rely on your responses. And, we've had conversations with OEMs, and to some degree, they'll show us, what their supply chain looks like. But, one of the ways that we would like to approach this is, we set the bar pretty low for getting into the showcase. But what we would like to do is eventually, do follow-up conversations with the firms that seem to be, willing to share and kind of negotiate, if you will, a higher level of transparency. And what we offer in return is what Dr. Roper described as a sort of DoD good housekeeping seal of approval, right? That we will in some way, and again, this is subject to negotiation with you guys, come up with a way of saying, yeah, we've kind of verified that these guys can do what they say they can do. And, you'll have your presence on the the trade show or the ecosystem page, but you'll get a gold star or something along those lines. And so as PK was mentioning, NASA just established this advanced air mobility supply chain working group. And my view, at least, is that maybe this working group, which I encourage you all to join, will be a forum for kind of negotiating how that transparency works, right? Because we want as much transparency as possible, but we understand that you guys don't want to give away your secret recipes either. So we'll use that forum to kind of strike a balance between those two needs, if you will. And since this is a market dynamics conversation, I thought I'd point out one trend we're seeing lately, which is a lot of the big tier one traditional aerospace suppliers are starting to double down on their eVTOL units. They're establishing new business units, they're opening new offices, they're hiring staff, and that's a great sign, right? They have real industry chops, and they understand how to work through the certification process. They understand that those products don't necessarily exist right now, but I thought that was a really great thing to see. The one thing I would say though is, if you're a big tier one supplier, and I won't name names here, please be mindful of the fact that Agility Prime is geared toward building the U.S. domestic supply chain. So to the extent that you have a multinational footprint, please give some consideration to your sourcing, because that's the sort of thing that Agility Prime is going to pay attention to. And we really want to work with those big suppliers, but we also understand that comes with maybe a little extra due diligence that maybe you're not used to necessarily in the past. So with that, I'll just say, we're witnessing history being made here. And, I often joke that, I'm going to spend my retirement sitting in front of a fireplace, bragging to my grandkids about having been involved with this. And I think that really is true. I mean, we should consider ourselves lucky to be involved in an endeavor like this at a time like this. It's really just a phenomenal thing. So with that, I'll give it back to you, PK.
Well, great. Thank you, everybody. Thank you, Steve, Dana, and Star. So I'm going to go around one more time and give you each 1 minute to less.
Anything else?
Using your
why don't you get Star
audio there.
So once you want the command. Okay, can you?
I'll tell you what, PK, you're cutting out a little bit, and we're getting towards the end of our time here, so we might go ahead and transition. Are you still up, PK? You seem to have lost PK. All right.
I lose them sometimes too.
That's all right. So thanks so much. Fantastic to hear across the board from NASA, from FAA. Dana, certainly appreciate everything that OSEA has done for this effort. We are now towards the end of our time here for this Team Up event. Cannot thank you all enough across the board, from those on the first day our members of Congress, our leaders from the Air Force, the fantastic leaders across industry, across academia, across the interagency, looking for those international partners that are out there. Really, it's exciting to see the cases of 30 different small businesses going out and reaching out to the universities there. It's exciting to see the small companies that are just getting into this business. It's really exciting to see the companies who've been at this for 10 years and now bringing some fantastic flying vehicles to the air. So thank you all for your time over the last couple of days. Thank you all for the work that you've done in helping us put together this ecosystem and for the conversations that have happened there. Be aware, as we said, the Agility Prime ecosystem between NASA and the Air Force is something that we intend to keep up, something that we hope becomes a good venue to continue to energize this industry, to make sure that we are identifying all the necessary pieces to move the industry forward. And one of the most important pieces to this of the resources ahead are the human resource. And so deeply grateful for our universities for being here. Many thanks to our 70 some ROTC cadets who've been facilitating and in our internship. And we are looking for those future opportunities to continue to engage the workforce, to be able to work at building out the supply chain, reduce the technical risk, these regulatory risks and the financial risks to bring this fantastic future to the present. Thanks for all for joining us. Expect several follow-on conversations in our weekly webinars, making sure that you're prepared for that August 10th deadline for the Small Business Technology Transfer Program. Looking forward to seeing you there. Don't hesitate to reach out if you have questions on that. Looking forward to getting the best possible proposals that we get so that we can get that research and development funded to accelerate this industry. Thanks so much. Have a good evening.